We're going to be doing a little handoff here. Today's talk is going to be tag team presented by David Lubinski, Tom Whitenack, and myself. I'm going to do a little intro and then a little of the wrap-up, but David and Tom are mostly going to do the work. David, as you know, is overseeing our website system, criticalzone.org, and Tom Whitenack, some of you know him reasonably well, others probably have not heard of Tom, but he's the person behind central.criticalzone.org, essentially the system that manages our, at the San Diego Supercomputing Center, the system that manages our catalog, which we have, which we'll be enhancing quite a bit in the very near future. So today we're going to talk about that process of registering data in the central catalog, but we want to talk about where we're headed more than where we've been. So we're going to focus on how that gets registered via criticalzone.org. So the first slide is just I'm going to present about 5 slides here and then hand it over to David. Just as a reminder, the architecture of CriticalZone data, this is a review from our first presentation, that the local CZOs are the repositories or the initial repositories for their files. So data files do not get stored, for the most part, with one exception, which I'll mention briefly, within a CZO data repository. That doesn't really exist, right? So you are all your local data repositories. What the CZO Central Data Management System does is that it adds functionality, and in particular, it serves as a way to catalog those files and then eventually serve up that catalog information to other data services to enable interoperability, which then in turn enable a much more unified and potentially automated data discovery and access process. So that's the architecture. It leverages lots of that's out there. It works on the basic construct of the internet, really, that there are data servers, which are not the same thing as the catalog of information. The catalog is like Google. It's how you find information, but then Google just points, once you do a search, it points you in the direction of where that information is stored locally. And the client would be the equivalent of a web browser or any software that we build. So we're trying to create these automated approaches to harvesting metadata and enabling data discovery through the catalog and data delivery from the server. So that's what the goal is. The catalog is something that hasn't received a lot of face time or a lot of recognition because the relatively limited amount of funding to date. But it's a Geoportal server, which is this metadata catalog built around geographic information systems, but with enhanced capabilities for all sorts of other metadata profiles. We are in the process of enhancing it, and you're going to hear a lot more about that earlier. So Geoportal can catalog any data file. We did talk about a very specific file format, the CZO display file, which was really designed as both a human-readable and machine-parsable format for sharing time series data. Specifically, it was targeting quasi-water one-flow web services, or not really the web services, but the quasi-hydro information system stack. So those files can both be cataloged at CZO Central, but then they undergo a second process where they get ingested into a quasi-hydro server, which enables a whole host of other processes. So there's been a lot of focus on that aspect of the CZO data system, and not enough focus on the fact that the Geo server can host any kind of data at all. So as I described in the first lecture, or the first seminar, we are in the process, after launching criticalzone.org, which did not happen that long ago, it only happened about 15 or 16 months ago, we realized that the website would offer a really nice entry point to enter the metadata regarding data files and provide links to that metadata, which in turn could be ingested by Geoportal. So we have kind of changed our approach. Rather than teaching everyone how to use Geoportal to register metadata, profiles for files and other resources like web service resources, that we are going to actually use our public-facing website, the back end of that website, to serve two purposes. One is to provide homogeneous and kind of harmonized web browsing capabilities, but also to enable these more machine-oriented approaches. So this is where I hand off to David and Tom to kind of present the rest, but I just wanted to give that little brief review of what this topic is all about. All right, David, you ready to take the ball? All right, I've got to escape out of here, find you on this long list of participants here, and there you go.
All right, so can you see my screen?
Not yet. You have to click share my desktop now that I've handed you the presenter ball. You got it? Just find.
I thought I had, but
find the WebEx layer on your cluttered desktop and click share my desktop.
Got it.
The big button.
Yeah.
There we go. Yep.
This wasn't going for a little bit. All right. So can you see it now?
Yes. Okay.
So Anthony gave a little, obviously, introduction to the topic and also to me, but I just wanted to point out that for those of you who don't know me, I am kind of embrace the old school term of webmasters and doing a lot of different stuff with CZO and CZOData.org. I'll be working about a third time. I'm funded right now for 2014. About 3/4 of that 1/3 are for data efforts, and the remainder is for the main website, much of which is devoted to getting the new CZO done. So there's two things I want to kind of hit today and kind of break it down a little bit. And the first is entering data set, what we're calling data sets into the CMS, but it's really just highly structured and significant metadata. No data is science data is actually going on at CZO.org. So as Anthony showed in that graph of the architecture, data sits on your own individual CZO web servers. And then the second part, and this, well, back up a second. The first part there is something we built, as you'll see in a little bit, about a year ago, after the launch of the website about a year and a half ago. And right now we're working on, as Anthony pointed out, trying to get machines, get the robots to do the work for us, and get some of this pretty structured metadata that folks have already been entering a significant amount of into this from the CMS into our central metadata catalog, which is the Geoportal. And so we're working on that now. I'm going to show you kind of the vision for that a little bit and show you some of the details for that. But I do want to show a little bit of history because I think it is important. But I will mostly move on to showing a little more nuts and bolts. But first thing I want to just point out was, you know, a year ago, really the way the setup was before we got these data sets going. Each of the CZOs, of course, have their website, the data websites, their databases. But as Anthony, sort of alluded to, only a small fraction of the data was making it into Geoportal, for example, and presumably a small fraction into domain-specific repositories like EarthChem and Open Topography and whatnot. And there's a number of reasons for that. And we've covered some of those in the past. I'm not going to go into this too much, but we're guessing that probably 10% or less, or in that range ballpark, of data sets had visibility in Geoportal. And as Anthony pointed out, there hasn't been much money to do much with Geoportal. It is in its default state, not that easy to use. So, and I think that's one of the reasons it hasn't gotten a lot of effort. But we'll have a plan, and we're going to talk about it today, for basically improving Geoportal to make it much more useful. Excuse me. So, for example, if you click on the Browse button there in the main menu bar there, you end up with this screen, which doesn't show you anything. You actually have to click through the tree to even start browsing. So there hasn't been a lot of effort from Esri's point to making it usable for the main public. It's been sort of geared for GIS specialists. And of course, more data is coming in all the time to the individual CZOs, and there was a lot of data that hadn't yet even made it onto their websites, let alone into Geoportal. So this was a year ago. We're kind of hit with this triple whammy of workflow of getting stuff in, Geoportal UI, more data coming in, and that's why a year ago, a little more than a year ago, in December of 2012, data group meeting in Stroud, we came up with this idea, as Anthony talked about using CMS, and we worked on it last spring. So we're going to show you kind of the results of that and describe a bit more about data and data sets. So I'm going to start with, a kind of an example data set. You should be able to see it on your screen. Is it showing up okay on the right? So this is an example from Catalina Jimenez. And it's kind of a typical example. The point I want to make here is that when we were coming up with our solution, we wanted to come up with something that was extremely flexible, that still offered a consistent way of showing the data set, so that once you parsed one of these data sets, it made it a lot easier to see the others. So the vision was that we needed to really be able to capture everything from a simple Excel file to, a whole series of LiDAR data sets. So we spent a bit of time working on that. And one of the things we came up with was this idea of having each data set be a sort of flexible container, that really pointed to one or many web-hosted data files that were on the individual web server. So in this case, for this data set, we have a title, obviously here, that's pretty structured, some basic information, keyword citation, and so on. But the sort of crux in some ways of this is this group of data here. So in some cases, there's only a single entry for a data set. In some cases, it might be more like this, where there's a whole slew of data files. In this case, kind of annually based, gap filled versus not, and so on. And these, as I pointed out, or as I mentioned, are pointing to individual files. In this case, on the Jimenez Catalina Jimenez web server. And if you look a little carefully in small print there, like underneath the little icon there, see, it gives you a little hint. So the second one down is a CSV file. So in this case, it's pointing straight to a data file. The one up above is a JSP, which just might give you, if you don't know what it is, at least clue in that it's something you don't know, but it actually is a Java server page. It's a web page. So in some cases, you might just point to a web page which has more information about that particular data set. So there's lots of options about sort of where you're pointing. In this case, it also gives you this container. In this case, this is Flux Tower, as a particular site, but they've captured a whole series of years worth of data. Another thing I want to point out, and it's kind of nicely expressed here on this example for Catalina Jimenez, is that you can also mark your data as private. So, in this case, if it's data that's, from recent years, you're not ready to make it public, it hasn't been quality controlled, or it's just difficult to gather and it hasn't been released yet, there's a little note here so people can contact you, maybe on a case-by-case basis, you're willing to let them out. But it prevents people from clicking through. So, for example, if I click on this private data set, then the system that has been set up by Matei at Catalina Jimenez will prevent me from actually getting to that CSV file. So backing up here a quick step, a couple other things I want to point out is that one of the advantages of this approach, besides being able to be really flexible and gather in a consistent fashion, all these varied data sets, you know, that span the whole gamut of geological science data, biological science data. We can also take advantage of the fact that we already have the CMS in place, so we can connect it to information that's already being gathered and is central to the organization of the CZO. So in this case, off on the right, there's a field area that this is within for Hermes. It might be multiple ones in a different case, as well as the authors. And there are also other connections like that. And so, for example, one of the advantages of that, besides having structure and sort of knowing what things are, that if I click through, I'm not going to do it right now, but if I click through the Hermes to the Hermes River Basin Field Area page, it will list this data set along with all the other data sets for that field area. The things are sort of cross-referenced across the CZOs. So the data managers at the CZOs have clearly been busy. There currently are 179 of these composite sort of flexible data sets in the system right now. I think the maximum number of what we're calling components, which is that data listing to your data resources that are at a URL. There's up to almost 30 now for some data sets. So many are 1, some of them are 5, some are 10, some have more. And if you sum all those up, we're now over 1,000 components. So we're looking at you know, over 1,000 files, and that is going to grow. And obviously, where CZOs come online, that will grow as well. And that's much more visibility to all this data than we had a year ago. So I think you know, we're definitely moving in the right direction. So if you haven't looked around, some of this is obviously review for some of you, but if you haven't looked around on the data sets, please do so, especially if you're one of the new CZOs and you want to kind of get some sense of what other folks are doing. I want to point out that we're just looking at the individual sort of atomic level data set here, which is obviously really important. But part of the power of this, of course, is looking both within one CZO and across CZOs, since we have some consistency at the data sets. So there's a data sets plural page which pulls them together. The number varies, obviously, quite a bit across CZOs. If we have about 200 and Catalina has 30, it varies quite a bit. But what I want to point out is that, you know, in this default view here, you can kind of, it's the number of data sets isn't, because they're containers, doesn't necessarily have to grow to a huge number. It's a browsable number in some sense. But we've also got it broken down here to looking at it different ways. So sometimes it's more helpful. I click through here to field area. For Santa Catalina, we can look within the structure of the website field areas that have been set up on the website. And sometimes that's easier to start browsing to see what's available. And this is all dynamic. So if you add a new field area and put new data sets within that, it'll appear. If you rename your field areas, if you change the hierarchy of field areas, and so on, this will be updated for you. So it gives you another way of looking at the data. So we also have, this is true for all CZOs, you could also click on the topic. And this is, as I'll show in a bit, is a semi-controlled vocabulary that's promoting some consistency, but not enforcing it across the CZOs. But that helps sometimes because not everybody uses the same sort of terminology. It might provide some clustering that when people are browsing, will help them find stuff, especially across CZOs, so that, you know, if you want to look for LiDAR at different CZOs, that's easier than it used to be for sure. And then so on sort of down the list. So I'll just hit one more and stop, but there's also these 16, or I can't remember, about 16 discipline tags that we're using throughout the main website, and that also provides some structure. So this is more disciplinary-based groups like biogeochemistry, biology, and so on. Somebody who's browsing that can help as well. And then, of course, we've also got search. So I'm just going to type soil, have that come up. So people that are using term-based searching. So within the CMS itself right here, we've got some capabilities. But as I progress through my portion of the talk and Todd takes over, we'll see how some of that can be leveraged even more helpful. And then, of course, I should actually probably just for completeness here, just sort of go up one level to the data page itself, which can provide some introduction and feature some data sets. We'll be improving this page to make it a little more obvious what the new resources the data sets page that will feel. So what I'd like to do right now is show you the back end of this, walk you through a little bit more, putting in data sets, talking kind of from the perspective of metadata and registering metadata, and then very briefly talk about how we're going to do some of the automatic syncing to Geoportal, and then very briefly talk about how we're going to improve Geoportal a little bit, and then Tom will take over from that. So as I move forward here, by all means interrupt if you've got questions. Probably best to get them as we go rather than having them come back, because we're going to try to cover a lot of ground.
Hey, David.
Yeah. Yeah.
This is Luke Spady from the Reynolds CZO.
Yep.
And I just really wanted to quickly focus on the data levels, as long as it's on the left, where we have data level 1, data level 2.
Right.
That's different from the CZO display file specifications, that the document that the CZO put together. I mean, I guess right now level 4 is considered data gap filled, right? And so it's showing data level 2. Are we going to, as a group, redefine those data levels? I guess that's my question.
This is Anthony. Let me jump in. We had quite a bit of discussion about this about a year ago, or maybe a little bit less than a year ago, within the data management team at that time. And the data levels that we inherited in the CZO shared vocabulary from Quasi were not really sufficient for some of the CZOs. So we developed an idea about what our data levels were going to be, but I have to say that I'm not really sure if that fully worked its way into the shared vocabulary. I'm not really sure if that got accomplished. However, in very recent discussions regarding where we're going in the future, we are going to support data leveling based on any system that can be externally resolved. So you can use the Ameriflux system for data processing levels, you can use NASA system, you can use USGS or Quasi system. So we're not going to force everybody to use the exact same system, but it's going to be resolvable.
And we're going to have to list that somewhere in the metadata, that data set.
That's right, but that's all coming down the pipe. So for right now, you can, keep that in mind. You can kind of do what you want to do. That said, I think we are also at the same time going to define an externally resolvable CZO processing level vocabulary, which we've more or less already done. We just haven't formalized it in documentation. So I don't know if that helps.
No, that's perfect.
Okay. So we're going to encourage people to use the CZO processing level, but not disallow people from using other processing level definitions.
Sounds good. Okay, so once again, interrupt as we go along here, but so I'm going to jump.
Yeah, I'm going to interrupt,
okay.
David, and just emphasize that point. To date, this hasn't been a whole lot of Q&A or discussion, these seminars, but we're very interested in making it so. So please do interrupt. I think it's really what these are all about. we want to answer people's questions.
Absolutely.
All right, David.
Yeah. So jumping into the back end, of the control panel admin for our particular CMS. I'm logged in as a sort of a test user here who has permissions within Boulder Creek, and I'm going to actually flip to the data sets listing, and I'm going to actually, and there's ways to shortcut this, but I'm just going to use it for a longer version here, and I'm just going to subset to the Boulder subset of the 179, 46 of them are from Boulder. And if I click through on that first one there, this is the main entry page for that. And I'm not going to go into great detail. We got a lot of stuff covered today, but I just want to hit some highlights. And this will be sort of a preview for those of you who are part of the new CZOs, the new 4 CZOs. And we'll be talking about this in future meetings of our Tuesday group for sure. We're going to encourage you, probably pretty strongly, not to start filling out data sets until you soft launch your site. Your site can definitely stand on its own without your data sets in there, and it's going to be easier just to transition if you wait until we've got your soft launch and then start working on entering data sets. So this is a bit of a preview. So the fields that are marked with asterisks are obviously required, and the four at the top here, location, start dates, and dates and topics are really critical. They form a composite title that we use for every data set that makes it much easier to skim that we've got consistent titling. And then the topic, as I kind of alluded to before, is this sort of loosely controlled vocabulary, sort of encouraged vocabulary that helps have provide some consistency of topic across CZO. You may come up with some terms that aren't in the list already, and we'll walk you through later, but basically there's another channel called dataset topics, and you just simply add a topic, and then it'll become available to you to add new data sets. So for example, if you were looking for something for soil, if it wasn't on this list, you could add a new one, come back here, and then it's available to you to add, use more than one to your data set. Most of the rest of this kind of here at the top is pretty straightforward. As I said before, we'll go into detail later, but the real crux here is the components. As we mentioned, there's over 1,000 individual resources that have their unique URL currently in the system, and this is where they're being entered. So there's a small matrix here of just sort of the key info for your data set, and the fields, columns on the left are the really critical ones. They are required to help promote consistency, but also in this case, you have to have URL to your data set. I should point out that some of the optional columns there on the right include a DOI. So if you have a DOI associated with the data set, you can put it in there. So that kind of gets a little bit at helping out a bit with the publishing with a capital P discussed in a previous seminar. Yeah.
David, DOIs, are those going to be individual? Is there going to be opportunity for us to register DOIs through the national CZO? Does that make sense? That service for a DOI, or is that going to become from individual institutions that are part of the CZO?
I'm going to let Anthony take that one.
Yep. The assignment of DOIs is typically done at the level of a data center that's hosting a long-term persistent archive of that data. So kind of in order to assign a data set DOI, there is an expectation that one, it's public, and two, it's going to be persistent, right? So that's what the DOI is supposed to do, is be a pointer toward that persistent location. Even if the location changed, the DOI never changed, and the DOI will always point to the present and most recent location. That's kind of the what you're promising. So the CZOs are not going to assign DOIs, but we're going to encourage you to, as you're making your data public here on CZO on criticalzone.org and logging these data sets into the Geoportal, which will then be discoverable by these other systems through machine-to-machine interactions, it would be really nice if you assigned DOI to your data sets. And so we'll point you to some of the possibilities. Kirsten described EarthChem as one of those, as a really good one. There are quite a few others. There's and really, as Kirsten described in the last presentation, these repositories are best if they are specific to the discipline. So there are repositories. Let's see. Kirsten did not present the full list. I think she dropped that slide for some reason. But there's the LTERs have their system, and actually. So if you're co-located with an LTR, it's a very biologically oriented system. There's actually now a project to make it generic, so even if you're not associated with an LTR, you can load into almost the exact same infrastructure. There are a whole pile of other ones, and they're just not coming to the top of my head right now. So, so in short. At this point right now, there is no CZO data center. Now, a CZO data center may be coming down the road in 2 or 3 years, but not right now. So maybe we should provide very specific advice on how to assign DOIs.
Yeah, and that's something that, from the CMS perspective, we could figure out where to write some advice, and it can link through up here in the instructions.
Yeah. Kirsten actually offered to have a very detailed walkthrough, hands-on walkthrough at the last presentation, and nobody really piped in either via chat or otherwise that they were interested. So maybe that will change. But we're very open to having kind of that more hands-on, like this is how you do it at EarthChem. And we know people at some of these other repositories, certainly the ecological ones, they would do a walkthrough in a heartbeat too.
Sounds good. So you can, of course, enter as many component data as you want. I should point out that the column in the right is going to be a really important part of our process for having harvesting of this kind of metadata into Geoportal. So the plan we're working at now is that every single one of these data sets, not just the component, but the data set encompassing the form we're looking at now, will have its own record, structured metadata that goes to Geoportal in a standard ISO format, so that makes it much more interoperable and discoverable to a lot of different systems. So there will be one that comes for every data set. There will be one that connects for every component as well. And then the part that we're working out, kind of getting going on more than right now, we've got some plans for how we're going to get those data sets from the CMS into Geoportal, how to get most of these components in, but in some cases, you've got metadata that are more unique than are described in this matrix here, combined with the data set itself, and we're going to need to have you kind of defer to your file somewhere else. The other part of this, and the interface may change a little bit, and we may use that same field for this, that may give us a flag on telling us, this is going sort of forward on actually using your entries right here in the CML to trigger a harvest of data values. So for example, one of your component data rows here might be some hydrologic time series data. It gets triggered here, tells the various systems involved to go pull that data, those data values off your web server, and get them into CZO Central as well as into the Geoportal. That's going to be sort of coming as a second step in the future. The first step for us that we're working on now, we'll be working on the spring, is just to get all this metadata that we're kind of looking at into a very standard format automatically into Geoportal. So I'm just going to kind of go quickly through some of the rest of it, but there's a number of fields, pretty straightforward stuff, but a lot of stuff about attribution, authors, and publications, and so on that are lower down. Standard stuff. We made a point of trying to have fields here that are going to provide a lot of overlap with a lot of different domain-specific repositories, as well as metadata standards. There are a few tabs across here. I'm just going to highlight. On the second tab here, there are some more stuff on DOI if you want to do it at this data set level, and if that's appropriate. There are also some places to put in grant numbers and so on. So that kind of gives you a flavor anyway. We're getting pretty late here at 22, so I'm going to wrap things up here a bit. It gives you a kind of a flavor of what's there. And to give you some sense for what we're working on right now, and the second step we're working on right now is getting all of this metadata, both at the data set and component level, automatically synced or harvested or whatever you want to use, ingested from the CMS, because you are entering information there into Geoportal. And once it's there, it's going to be in its very standard format. It's going to make Geoportal more powerful. It also makes it possible for us to get it eventually down the line in other systems. And then, as I pointed out before, there's also this idea of using the CMS to help trigger harvesting of your header files as well. That'll be sort of a second step that you'll be hearing about. So this is all work that we'll be doing in the spring. So as we pointed out before, this is for the current data portal that Tom has set up for us. And I just wanted kind of to highlight that that the CZO data group has come up with, I think, this great plan. I'll be helping out with it, but for reskinning this portal, and reskinning isn't even the right word because it's much deeper than that, to make it much more usable. And we're going to be able to use code that already exists. So Emilio Mayorga, who's on the CZO data group, is a key part of this West Coast Ocean data portal Tom may mention, and we'll no doubt talk about this more. But I just wanted to kind of get it in mind for you that we're not going to be stuck with the old Geoportal. So that this is running the regular Geoportal, but there's a very heavy reskinning and work done on top of this to make it much more usable. So, for example, if you go over to Discover here, there's much faster and ways of browsing and getting to the data. So this is just classic faceted navigation like you see in a lot of e-commerce sites. So we're working out now what the facets would be, and there's some logical ones from our CMS. So, for example, like instead of categories here, you might just have the CZOs with your list of all 10 CZOs. So you could quickly click on one, and you very quickly get everything for your CZO, for example. But then you could add some other facet. In our case, we've got the discipline tags, which are obviously to be used, but there may be some other things related around authorship or topics and field areas that might be able to help. And I'm not going to go into detail now, but this system is much easier to use than the default Geoportal. So I'm going to go ahead and let Anthony hand off to Tom, unless there's some kind of quick questions that I can cover right now.
Again, Luke at
Yep.
Reynolds.
Yep.
Really quickly, and it wasn't exactly clear, but you might have covered it, and I just spaced out for a little bit. Where is the data being hosted? Is it being hosted at the individual CZO, and we're just linking to it on the National CZO website, or are we actually going to be uploading our data to the National CZO?
The former. So your data sits on your server, and everything I described is really just metadata. Our ways of making your data more visible in a centralized way. In two ways, at the regular CZO website as well as this Geoportal.
And next question, so say our individual CZO set up a series of Geoportals to share data amongst each other. Could we fill in so you're going to be harvesting the data portion to fill in the national CZO. Is there a way to harvest from the data portal to put into the data? Does that make sense?
I'm kind of lost you there.
You said you already have a Geoportal served up?
Oh, we're identifying ways to share preliminary data amongst our 3 institutions that make up the Reynolds CZO.
Okay.
And as part of that, we were thinking about using Geoportals as the front end of that. And to that degree, then we can very easily, the national CZO can harvest our metadata off of our Geoportals, individual Geoportals. I was wondering if we're still going to have to go through the rigmarole of entering all the data into our individual Reynolds CZO data section, or if it can be harvested, if it can automatically be filled in as well.
You mean basically a backward sync from your Geoportal metadata profiles into the content management system that runs the website?
Yeah, I know that's asking a lot. I know that.
Yeah, we talked about that, and that's pretty low on our priority list to implement.
We actually, when we first rolled out the CMS, we did a little bit of that, and it's pretty tricky because the data you have in Geoportal, depending on the schema you used, might not populate everything required from the CMS.
That's right. In fact, the CMS has more information in it than is in the default metadata schemas used by Geoportal. So Tom and David Valentine and Ilya at San Diego Supercomputing Center went through really carefully all the different ISO metadata profiles to find one that would handle it. So Geoportal can handle it, but it's not the default that you'd likely be using. I mean, I suppose we could share that with you, but to get backward, so it helps that you're just getting started. Right? If you already had an existing Geoportal, it would be really impossible to fully do, but it would still be really tricky.
I mean, just as a data manager, when we're asking different researchers to fill out the data that's necessary, it's almost nice just to go to them one time to get all the pertinent information, so we don't have to continue to bug them about their data set. If that makes sense.
Absolutely. That was a huge, important consideration that we had when we moved to the system that we just are presenting to you now. That's why we went with kind of really focusing on the website as a way to get this metadata profile up, because it was easy. The CZO data managers, a year ago, thought it was easier than trying to deal with the Geoportal. They'd already had experience with it for other aspects of the CZO. And in fact, a lot of your PIs may even get experience with the back end of the content management system. We want to really roll out, in fact, relatively soon, one of these separate seminars is going to be about trying to get investigators with logins to the website so that they can be constantly putting content up there, so they'll be familiar with it. But that said, I mean, one of the things that we did a year ago, and we could do that again, is we created these Google Docs and Word documents that you can basically hand to your PIs to fill out. And they'll fill out one of these forms, and you can cut and paste that information into the content management system on the website and use the same information to fill out a metadata profile on Geoportal if you have to if you decide that doing your own Geoportal makes sense to you.
And then last question, what is the metadata center that you're using for your Geoportal?
Tom?
We're using the ISO 19115 is what we're migrating to. A lot of the data that we had in the earliest versions was Dublin Core, which is really not sufficient for what we want to put in there.
Can you repeat that one more time?
We were using Dublin Core, but now we're moving towards ISO 19115.
Thank you very much.
Yep.
And ISO 19115 has a couple extensions to it, which we're also using. Like Tom can explain that more, but maybe we'll hear about it. But if you should probably email Tom for the full details.
Okay, so should I try and get through this in 10 minutes, or we're just going
to do your best, and we will probably wind up going over past 4, I guess, is my guess.
So I was basically going to try and explain how registering data at the central.criticalzone.org works with the hydro servers that we have set up here, and how those are then in turn visible from quasi-clients. I want to talk about the display file formats that are currently existing, and we can discuss a little bit on how those are probably going to be changing in the near future. And then also just kind of explain the relationship between the different sites that we have set up. We have 3 different domains we're throwing around, and how those relate to each other. And then I'll talk a little bit also about Geoportal and the future of the interface for that. But I actually might not get to it, but David kind of touched on it well enough, I think. So the CZOData integrated system, as this project started out a few years back, the big push was to leverage existing technologies and standards that were available. So that's why the display file is set up off of LTER. We're pushing data into what is the quasi-HIS hydro server. And we're trying to work towards the same things using the OGC standards and possibly make an earth chem type or a sampling style of a display file as well. The general publication system. Now, I threw this slide in here, even though it's a little bit old, but it kind of explains in general what we're talking about. Your data would be hosted on a website on your service as flat files. These files then get pulled into a harvester here, are archived. They're double-checked against the shared vocabularies and ontologies, and then metadata is created as well as standardized CZO services. There's a lot of little steps that is being performed on every data set that you load, but then the end result is that you have data in a format that's easily discoverable, easy to work with for other people, and it makes your data more powerful in the long run, and that's kind of the reason why we tried to do that. The CZO Central Web Service Registry is essentially a mock-up of what was the HIS Central product, but what this does, it takes it into a separate level, which allows you to configure your actual hydro server. So right now you're seeing each page for a couple of the CZOs that we have in the system. Additionally, I got my slides out of order. I'm going to just skip down here. You'll have this additional page. Ooh, how do I get down there? Okay, so here is the configuration page, which allows you to manage your display file configurations and view ingest logs as well as instantiate ingest on the server. It's not a very pretty looking page, but it's not necessarily intended for public viewing either, so it wasn't as important. And in the end, this is one of an example of what your data will be consumed in, is a Hydro desktop type client, which can geographically search based off of certain keywords of your CZO perhaps, and then pull the data directly in from our Hydro server and this displayed in a live graph. This is a general idea of what our web services model is and how we're trying to implement a lot of different publicly and standardized services for the catalogs, for the ontologies. We are working towards the geochemical. We have the time series. But that's kind of the model that we're aiming for. We haven't achieved everything in all these spots here, but this is the idea. So it relies heavily, the CZO data publication model is going to rely heavily on you guys to generate the display files. And it's modeled on the LTR, and we'll go into more detail. But this file is what's generated, is what's referenced in the config file, and they're picked up and registered at the Hydro server. Then the data within those files would be exposed as quasi-HIS WaterML compliant services. Okay, I'm going to try and skip through here. So this diagram kind of explains a little better the flow, I think. So there's a main data interpreter processes. So your CZO raw data files or display files are going to be registered on your server and referenced in a configuration file. The data interpreter will extract the metadata from those display file and publish that straight to the Geoportal immediately. Additionally, on top of that, it's going to go into the ODM and display all that data into the ODM, which then, in turn, publishes the data as WaterML services, which can then be harvested into a centralized catalog, which then has search services. So then you can access it via rich clients, such as the Hydro Desktop, also by Quasi. Anybody have any questions about this? So here is the display files. We have a configuration file which points to other files. Again, so these are display files as they were designed a few years back, and we're kind of in the process of rethinking and how we're going to do this, so this is all subject to change. But currently, a configuration file will point to all the data needed in order to load values into an ODM, or the observation data model, which is the Hydro server database schema. Types, we need methods, and we need the location of the data files. And that's kind of what you're seeing happening here. Sites file is pretty standard. It's this top line here. It's a CSV file. Basically, describe your site with geographic terms, some context names, and possibly other information that is relevant. Methods file, we're only looking for 3 basic fields. It's pretty simple, just a code, a description, and then possibly an external link. The header display file, well, I mean, these two terms kind of get conflated, but this is actually what is the display file, but we also call it a header file sometimes because people have been putting a .hdr extension on it. It doesn't really matter. But you have some key components here, and these are all going to be read programmatically in order to generate the XML metadata. But you have a title, abstract, investigators, variables, keywords, citation, publications. Those are all general metadata. Down here into the default parameters, we're actually describing default values for every column. So it's kind of, these are applicable to what gets to columns. So for every column, they're all using the same stream water, time support units, sample medium, etc. So it can kind of, what goes in the default parameters can reduce what's in your column values, but each column needs to be explicitly defined. And typically you have to have, and you also have to have at least one column in your CSV files for it to work. And that date format has to be specified how you, such as this, like YYY, that reflects what is in your date column. So this is the part that gets probably the most complicated in developing it. But so here I got my slides out of order again. Sorry. Okay, well we'll skip on to this. This is how I see kind of the critical zone and the search and the HIS Central, or the central.criticalzone.org site. The main files are going. I mean, the main public face for our services are all going to be on the www.criticalzone.org. But from there, the data files that are registered, metadata will also be extracted and put into Geoportal. And then for some, and this is future because we haven't developed this yet, but if a data file is registered, it is also a valid display file, then we can also look to programmatically have it automatically registered with a Hydro server. We're not there yet. So, and right now we're currently working on getting the metadata out of here into the Geoportal as our current focus. So yeah, so in general, main facing public site, search is search. And the central is essentially going to be not intended to be public sites, only used for the data managers to display files ingested into a Hydro server.
So one of the things that needs to happen, maybe Tom's about to get into this, but essentially all the data managers should have a login to central.criticalzone.org. So you should be able to get a hold of Tom's email address, email him, and he'll set you up.
Correct, yeah. And in fact, you can go to the site and register an account and let me know which account you registered, and I will tie you to the service that I've created for you. So each of you have a new Hydro server that is currently set up, and but it's empty right now. It doesn't have any data in it. So it's a database with web services connecting it, ready to deliver data, but no data.
I have a question really quick.
Sure.
And I don't know much about Hydro server. I haven't worked with it, being a remote sensor. But how data redundancy? So we currently already have a group here that is hosting all the data onto a Hydro, into ArcHydro, or what's it called? Sorry, I completely forgot to space it. But does it matter if there's a redundant data set like that on the system? Do you encourage redundant data sets like that?
Well, I would say it doesn't matter, but in the end, it's kind of pointless too. I would say, because if you have the exact same data already being served with Hydro server and it's already registered, are you from Reynolds Creek, I take it?
Yes, but the group they're currently harvesting Reynolds data to put on the Boise State. Yeah.
Okay.
If anyone currently has a Hydro server or is migrating to a quasi-Hydro server, then you should bypass this and just have direct Hydro server to Hydro server communication.
All right. Thank you.
Yeah. Yeah. Originally, when this project started, also the display file format was kind of one of those required for data publication purposes. They made it a requirement of the CZOs that the data had to be available for download in a human readable format. So that's what it was designed for. So it did fill two purposes at that time. So I'm not sure, would they still have to do the display file?
Yeah, let me restate that. I think the data still needs to be, so the problem with a Hydro server is that it doesn't actually provide archiving capabilities to data sets. So, and it's definitely not human readable or human browsable. So we should go over the details about this, but if you have a Hydro server, you should create the server-to-server connection for the machine readable stuff, but you still need to load up the data sets as display files so that they can be archived. There's really no other way to do it. So are you done, Tom?
Yeah, pretty much, unless you want me to go. I was going to talk about some of the faceted search capabilities that we're going to build into the Geoportal, as well as the West Coast portal stuff. But, I mean, we kind of already touched on it with David. Go ahead.
I think that it would be worth continuing. I know that it's getting, it's past the hour now. We've been going for more than an hour. If anyone needs to step out, that's fine. And you know that you can always come back because this is recorded and go to the website that's on criticalzone.org about the seminar series, and you'll find links there within a day or two to be able to watch the recording. So feel free to sign out, but I think we should keep on going. I've got about, I don't know, maybe 5 or 10 minutes of discussion to just begin people thinking about where CZO display files are going. And then Tom is also about to talk about where things are headed in terms of the development of Geoportal. So let's continue.
Okay. So we were talking about faceted search. So we have set up what is called the Apache Solr, which is what indexes against the facets of Geoportal registered documents. So you can create your own facets to which can be searched against, and it goes faster than the typical Geoportal. So I want to just refresh this because I can't always figure out how to work this thing. So this is the default client that we have set up, and it works with the data that we have. And you can see that, like, for all the documents, there's 389 that have hydrology terms. Some of them have some junk information in here, latitude, longitude, but 118 of them have temperature. So what we're working towards is making the metadata more compliant with this server. So we're going to have to kind of work on the metadata so that we can have these categories correctly reflect what's in there and more usable, so that there's not as much junk, but then also work to have this client be a little more user interface than what you're seeing here. The West Coast Oceans application here. Pretty slick, because as you can see, when you click things, it's pretty instantaneous and jumps. Of course, they only have 189 documents, and we already have well more than what they have. But the idea, I think, is it should be a lot better once we get it finished. Anthony, was there something specific you wanted me to touch on?
No, I think maybe the one question that we have for folks, and people can shout out or type, is or send emails later, is the faceted. There's well, first of all, that Geoportal, if you want to click on it again, or either one, either the West Coast or the yeah, right there. You can see there's a free text search, there's location searches, and then there are these what's called faceted searches, which are a little bit faster and kind of pre-canned. They help guide you. Here, there are categories, issues, and sources. We just need to decide what facets we want to use. And to us, there are 3 obvious ones. A facet has to make sense. The list can't be too long. So the obvious ones are, which CZO did it originate from? And the other one is, which of the 16 disciplines is this data set tagged with? So those of you who have spent time on our data set pages know that that's pretty fundamental to how that works. Things like authors or data topics, like what we were just looking at, rain or precipitation or something, which is a little more granular than a discipline, or specific field areas like, you know, White Clay Creek, or you know, I don't know what some of the other locations are that you guys deal with, but some of the very specific things, those can all be accomplished with the free text search. But the question is there another facet other than CZO and discipline that makes sense? It's an obvious one that people will use. So if you can assist us coming up with those ideas, that would be great. I think we can accommodate 1 or 2 other facets.
Agree. Yeah. And in this one, they're showing the location. I think we could probably try to implement, I mean, if we could, because within the Solr is the ability to search against temporal extents as well, which I know is available in a lot of the data. we're not recording, the metadata that I currently have loaded in here doesn't necessarily have it. I mean, you can see it like in this document, it's stated here, but if we go into the XML of the actual data, it's not necessarily in a parsable metadata field that would be, you have a spatial extent, and this is a Dublin core document, which is pretty thin. But as we're talking about moving towards an ISO 19115, you know, data envelope comes as, here's your spatial envelope, and then also here's a temporal envelope. So we'd be able to take advantage of something like that.
Yeah, just to give you an idea of the work that's required to kind of expand that, I mean, we're probably going to dump everything that's currently in Geoportal and start from scratch based on the website, actually. I mean, we're thinking of the metadata that's been loaded in the website as being much more complete and robust and the ultimate primary source. And that wasn't a decision that Tom or I or any of us on the project team came up with. It was actually in concert with the data managers almost a year ago. We kind of decided that we weren't going to try to do two-way syncing, that we were just going to really think of the content management system as the way to develop these metadata profiles.
Yeah.
All right. Should I move on to talking about where we're going with display files and wrap this up in the next 5 or 10 minutes?
Sounds good.
All right. Okay, I'm changing myself to be presenter. Let's see here. I'm rearrange some stuff between my screens. Okay. So here we go. So this is a slide that I presented on our very first session. It kind of described the very basics of the CZO display file. Tom went through a little bit more detail, and anybody who wants to have all the detail, you can go to this link right here. It's relatively easy to find this if you go on to criticalism.org and start combing around in our national data pages. You'll find this link. So, you know, the requirements were that it were machine parsable, human readable, and the extra requirement was that we could parse it into a quasi-hydro server, which required it to conform to the ODM 1.1 data model and the CZO shared vocabulary. Sorry that my phone is ringing in the background. Can't really figure out how to mute that. All right. Let's see, I just went too far here. The solution, of course, is what we just talked about, and but however, it had issues, right? So the issues were that there were quite a few parsing errors. We were really relying on data managers to come up with their own ways to develop these files. We would like to provide a little more assistance along those lines. But one of the reasons there were parsing errors is because it was kind of a unique file format. Nobody else really had them. The only parser that existed in the world was the one that Tom had created. And we found that Tom's job, there were so many parsing errors that Tom kind of often took the approach of customizing little tiny roundabouts back to bypass the errors rather than actually force the data managers to fix the errors, which, you know, ultimately isn't a sustainable approach. So we'd like to do a better job at that. It was really all about formatting, not really following the specification closely enough. But we realized that it wasn't easy to do. So another one was limited applicability to disciplinary data. You know, it was designed around hydrological data, supported time series from a single location relatively well, but it couldn't handle complex relationships, spatial relationships such as a soil interval. It couldn't handle hierarchical relationships like specimen genealogies, you know, subsamples of a subsample or a subsite of a subsite. It didn't really handle a whole bunch of other stuff. And it only accepted terms from the CZO shared vocabulary, which as you know, as we mentioned, was based off of the quasi-shared vocabulary or control vocabulary. It was a little bit customizable, but the funding to maintain it was very weak, and in fact, the person who was maintaining it left at one point, and now we kind of have someone else who's pitching in as best as they can. But it was kind of a hard to maintain system. The information model behind the display file was quite flat. So it wasn't really rich enough for a lot of modern data systems, including ODM1 for that matter. I mean, it was a relatively lossy way to store data. The data that was already allowed in ODM 1.1 was not fully encapsulated in the display files, and certainly more complex systems couldn't be handled, such as where we're headed with ODM 2. And lastly, the CZO display files did not meet archival requirements. So data repositories that are putting DOIs onto data sets really want that data set to be quite clear, so that, you know, tens to hundreds of years down the road, people can look at that file and understand what it is. Or even, you know, if somehow someone finds a file on their desktop after they downloaded it 2 years ago, they should be able to figure out what it was. So Tom didn't mention this, but we allowed, after a request, to separate out the metadata in the header into a separate file from the actual data value, the comma-separated data values themselves. So that was something that was allowed after a CZO data manager requested it, but somehow that became standard practice, and that really just can't, that does not at all meet archival requirements. So that practice needs to change. And then there were other little things like no explicit in-file references to these sites or method files. You know, you had to go to a separate config file, and so if that system fell apart, all those links would fall apart. So another one, which is kind of minor, but not too minor. I mean, a lot of people want to look at these files in Excel, and they did not open nicely in Excel, even though they were largely CSV files. At least the data was comma separated, but the header information, the metadata, had commas in weird places, and things would just end up looking very strange. So the requirements for the CZO display file 2 are really not all that different than they were for version 1. We want it to be both human readable and machine parsable. You know, we don't want to move toward XML. That's a reasonable format for exchanging information between computers, but you open an XML file in even a text editor, even a good text editor with syntax highlighting, and it's really hard to read. It certainly can't open in Excel or something else. We want it to conform not only to ODM 1.1, but also to ODM 2, because ODM 2 can handle all those much more complex data needs for disciplines like soil horizons or radial horizontal offsets with depth-dependent offsets, so it can handle complex relationships between sites and specimens, or sites and their sensor locations. So the solution that we're considering is to use JSON formatted text. So it's actually a text file, but it follows the JSON or JavaScript object notation syntax, which is now massively used on the internet. Essentially, every data and web server supports JSON these days. It's not just about Java; it's gone way beyond that. But Java itself stores data in these kind of weird, not really weird, but these, it typically stores data as a label data value pair. That's kind of the standard way that most Java and XML is noted. But Java can also handle comma-separated data arrays, or in other words, CSV tables. So you can embed a CSV table inside a JSON file. So this makes it much easier to parse, and I'm going to show some examples. We, of course, are going to continue to have a header with detailed structured metadata, but that will be built into the file itself at the top of the actual data values. And that header, not only will it be much easier to parse because it's JSON, but there are evolving approaches to create schemas, such as those developed by jasonschema.org, to validate or give structure to what is being expected by that header. XML has that well developed, and JSON is beginning to develop it too. The separate sites and metadata files are an excellent idea, but we want to make sure that there are clear links within each file. We are really just getting started and working on this specification because it's been so dependent on us finalizing ODM2, which we've just recently done. But I'm still going to give you some examples here. So I'm going to escape out of here and just kind of show you what I'm talking about by opening up a text editor. So hopefully this isn't too small. I'm not sure I can increase the size here. But this is essentially what I think you should all be able to see. One of the header files for water level data. It looks very similar to what Tom showed. And it is reasonably human readable. But it's kind of got some particulars about how things are parsed, right? The label for this value is separated by a comma. So the first comma separates out the rest of this, but there are other commas in that string. Same thing goes for this. So, there's a custom parser that Tom's developed that's done it. Down here, the separator is a period. The data values are not included. The data values, when they are included, are actually not supposed to have any header information at all, or they typically aren't, although you can do it, and we created these short labels. So what, if I were to convert this to JSON, this is what it would look like. So I'm just going to toggle over to this in JSON. Now, most text editors, as you know, can do syntax highlighting, which this one for Mac, it's a free software for Mac called Text Wrangler, can do. Almost all of them can handle JSON out of the box. And you can see here that JSON, there are a few squiggly brackets, but otherwise you can indent this thing really nicely so that the hierarchies are really easy to see. The indentations are really just a courtesy. They're not necessary for this parsing. It can have all the same information, and you can include the data in a data block, just like what I have, just as it's shown here. And that data block could be opens up very nicely in Excel. In fact, if I put CSV on the end of this, it no longer syntax highlights. This is the same file, but if I open that identical file in Microsoft Excel, let me find that file on my other screen. Here we go. Identical file in Microsoft Excel. It opens reasonably nicely. There's nothing too strange about how this parses at the top, although actually the keywords parse separately, not so beautifully, because that's a comma-separated list. But the data values, if you do it this way, parse out very nicely. You have to ignore these rows to kind of close every line, but otherwise this kind of works. So I'm going to show, there's actually another format that's very similar to JSON, which we're exploring, called YAML. And YAML is a superset for JSON. It's also parsable. It makes it even, it's trying to be even more readable than JSON. So if I click back and forth, you can see that a lot of the double quotes for highlighting text disappear unless you have commas inside your value. A lot of the other squiggly brackets and other things disappear, and essentially that parses into Excel very nicely too. It can handle all these exact same structures. If I show you what it looks like in Excel, it looks like this. It actually parses even a little bit nicer in Excel. Not all that different. So this isn't really, these are all still just display file version 1s. As a display file version 2, we're talking about doing things like, if I go from, you know, here to here, we're talking about adding a lot of extra information, like, first of all, labeling the file format, its version, a profile. This is a hydro profile, which might indicate it's heading toward a hydro server, adding explicit header information, being a little more consistent about the different attribute levels, about where these site files are located, et cetera. So we're heading down a direction that looks like this. I'm going to jump over to an example of parsing this data. So I just brought in a Python IDE called Spider. You could do this in MATLAB. It works just as well in MATLAB. So if I do something as simple as import the JSON library, so now it can understand JSON commands. I've kind of preloaded these lines so I wouldn't have to type them. I open up my JSON file and read it. And then I load that JSON file to an object called data. It immediately parses out what's called a dictionary, which is a hierarchical data type. So I can, you know, drill in on this data set. Everything gets parsed out perfectly to a whole pile of different levels. You know, in MATLAB or Python or R, this is just easy as pie. And the beauty about JSON is not only are there interpreters in all these languages that we might use, but there are also validators online. So if you're trying to figure out if you've set up your JSON file properly, you can actually just paste that text into a web page. I should have found an example. I forgot to do that. But there are like a dozen of them. You paste it into the web page, and it will tell you if it's a valid JSON, meaning if you've forgotten a bracket, squiggly bracket somewhere or something or other, if the commas don't all, you know, if there aren't there, I don't know, if there's an extra comma somewhere or something like that, it will tell you. So you don't have to rely on it failing at central.czo.org to realize that you've screwed up. And a lot of times these, you know, because so many people are using JSON, the failures are much more well documented. I'm going to point out that to do this in YAML is just as easy. I'm basically repeating the step, but now I'm opening up a YAML file. I imported the YAML library to give me the YAML functionality. And the last thing I'm going to do is create data2, which is an object created out of the YAML library. That's going to show up here as something that looks really similar to what we had before. Same kind of beautiful parsing. YAML is not quite as widespread as JSON, but there are parsing libraries for all the major languages. JSON really is built into everything. YAML is not quite, but it is being increasingly used. As I pointed out earlier, YAML files are a little easier to read by humans, but not that much harder to read, or not that much, you know, JSON isn't that much harder to read. So that's where we're headed. I don't know if you guys want to give me early feedback on that, but we will be developing this further and presenting it to you in more detail at a later date. Any thoughts? All right. So, silence, worn out. This has gone on for a long time. Thank you all for paying attention. We, as I pointed out before, are recording these videos. You can watch the recordings for the first two of these. We will post both the recordings and the slides as PDF files here within a few days. And the next two seminars are scheduled here. Anybody have a question or a thought?
Nothing other than that. I really like the approach that you guys are going for. This is data for JSON or YAML. Definitely way more readable and stays away from the XML troubles.
Yep, way more readable, almost as easy to validate as XML, much more compact, and you know, Kirsten Leonard is thinking that she's toward wanting a JSON file as being the preferred way to archive data in the EarthChem repository. So because it isn't a proprietary binary format such as Excel, it can be read by anything and will always be readable by anything. And it does enable that hierarchical metadata tagging to happen much easier than an Excel file does. And it can be validated against a profile. So there's all sorts of reasons why we might head in that direction.
Sounds good.
Okay. Thank you all, and we'll talk to you next week, same time, new topic. Future CZO data systems and an intro to observations data model 2.0, which we've alluded to many times. All right, thank you all.
Thanks much.
All right, signing out.